Hey guys, today we're going to be talking about how to multiply polynomials. So first of all, what is a polynomial? A polynomial, meaning multiple numbers, is an expression made up of multiple terms. These terms can be variables and constants, and they can have coefficients. The terms cannot be divided by variables, however. For example, x squared plus x plus 3. This is a polynomial. It consists of three terms, being two variable terms in the x squared and the x. Should not have erased there. The x squared and the x, and a constant term, which is the 3. Moving on, we have 3x plus 4 plus 1 over x. This is not a polynomial. While there are two valid terms, being the variable term with a coefficient and a constant term, the third term is being divided by a variable, and therefore that means that this expression is not a polynomial. To understand multiplying polynomials, we must first look at a concept called the distributive property. Skip ahead if you are familiar with this already. The distributive property goes like this. If you have an expression in brackets and you wish to multiply it by something, you must multiply every term inside the brackets individually. I'm going to use something familiar to illustrate this first, and then show how it's further applied. Say we have an expression in brackets 4 plus 3, and we wish to multiply it by 6. Let 4 and 3 be each line segment 4 and 3 units long. Let 6 be another line segment that's perpendicular to this. Now, as you can see, this lays the foundations of a rectangle. And what we're going to do is we're going to find the area of each rectangle. If we do that, we can find the area of the shape as a whole. And the area of the final shape is going to be our final answer. We can do this in parts. 4 times 6 is 24, 3 times 6 is 18. Combining the two, we get 42 as our total area. Now, you notice how we've arrived at the exact same answer as if we've just done 6 times 7? This is the core concept behind the distributive property. You can split multiple things into parts and multiply them separately, and then you add them up at the end, and you get your final answer. Algebraically, what you can do is you can simply rewrite the equation as previously shown, and will be shown again. With variables, the distributive property works the same way. Let's say we have an expression x plus 1, and we want it to multiply by 3. Again, we're going to do the same thing like we did previously. Let x be a line segment x units long, and 1 be a line segment 1 unit long. Again, we're going to set up 3 as the other line segment, and we're going to form two rectangles. So what's the area of the total rectangle? We can figure that out by figuring out the area of each individual rectangle. So the area of square 1 is 3 times x, which is just 3x. The area of square 2 is 1 times 3, which is just 3. Therefore, our final answer is 3x plus 3. Fairly simple. Just because it's a variable doesn't mean that you can't still distribute into it. Now let's look at some binomials. Let's say we want to do the multiplication of x plus 2 times x plus 1. We'll set up our sides just like we did before. X plus 2 on one side and x plus 1 on the other. Now let's find our areas. Notice that there are 4 rectangles created this time. X by x is x squared, so our first area is x squared. X by 2 is 2x, so our second area is 2x. Look, we've distributed the x plus 2 into the x term. Now we've got to do that for the 2 term as well. X times 1 is 1x, so our third area is 1x. And finally, 1 times 2 is 2, so our last area is 2. Adding them all up, we get x squared plus x plus 2x plus 2, or x squared plus 3x plus 2. And that is our final answer. So there are faster ways to do this. One of them is called FOIL, which stands for first, outer, inner, and last. What do I mean by this? Let's multiply x plus 1 times x plus 2, just like last time. So the way FOIL works is it's 4 operations when you're multiplying a binomial. You're going to take the first, and you're going to multiply the first of both brackets. So we get x squared. Then we take the outer. We're going to take the first term times the outer of the second bracket. Then we're going to take the inner, which is the inner term times the first of this bracket. And then we're going to take the last, which is the last term times the last term. Another way to think about it is this first and outer step is basically just multiplying this x into this term and this term. The inner step is multiplying this one into this and this term. So we're basically just distributing. So let's try another one. Let's try x plus 2 times 2x plus 1. Again, first, we're going to take the first of each bracket. That will give us 2x squared. Then we're going to take the first term times the outer of the second bracket. So that gives us plus 1x. 1x. Then we're going to take the inner and multiply it by the first term of the second bracket. So now we get 4x. And then we're going to take the last term and multiply them together. Plus 2. So then our final answer is just 2x squared plus 5x plus 2. It really doesn't matter what order you do them in, so long as the x is multiplied by these two terms and the 1 is multiplied by these two terms. You could do, let's just say, you could do this one, then this one, and then you could do this one, and then this one. It doesn't matter, so long as you multiply each term by each of the other terms in the other brackets. All right, I know that was a lot. Rewatch the video if you have to, but we're going to move on. We're going to try a few examples. So the first example I want to try is fairly simple. This is just distributive property. 2 times x plus 2. To solve this, we can just distribute. The 2 can go into the x, the 2 can go into the 2. And then now we're left with 2x plus 4. X times 2, 2 times 2. Fairly straightforward. All right. Again, this is another distributive property question, except we have a variable out on the outside. It's the same concept, we're just going to distribute this into both. Now we have 4x squared plus 4x. Moving on. This is our first FOIL problem. X plus 3 times x plus 4. So we're going to do this the FOIL way. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. And there is our final answer. Number 4. This is another FOIL problem, but this is also an introduction to something that we're going to get into later on in the video, which is called the difference of squares. But again, we're going to do this through FOIL for now. X times x, that's x squared, minus 3 times x. Oh, sorry. No, I should be doing the x term first. X times positive 3, that's 3x. Now we get into minus 3 times x. Okay. Plus minus 3x, which is essentially just minus 3x. Minus 9, because we have negative 3 times positive 9. That gets us x squared minus 9, because this term and this term cancel each other out. Cool. All right, the fifth term. This looks a little bit scary, but it's the exact same concept as the others. So we're going to take the first term, multiply them together. That gives us negative 2.5x squared. And we're going to take 5x times negative 3 plus negative 15x. Then we're going to take the next term, 2 times negative 0.5, so that's going to be plus negative 1x. And then we're going to take the last term, plus negative 6. So now we get negative 2.5 x squared minus 16x minus 6. And there's our final answer. It's the exact same concept for all 5. just slightly messier numbers. You guys gotta remember to distribute. That is the key to all of this. Let's take a look at some polynomial multiplication. So the same concept applies. Distribution is king. We are going to be distributing a polynomial into another polynomial, in this case a binomial into a trinomial, to find the final answer of this expression right here. So let's take a look at this. We have x squared plus 3x plus 2, a trinomial, multiplied by x plus 2. That is a binomial. So we're going to be using the distributive property to solve this. We're going to multiply every term of the trinomial with the binomial. So this is going to look like x squared times x plus 2 plus 3x times x plus 2 plus 2 times x plus 2. If you were to factor this, you would actually get our original expression. You would just factor out the x plus 2. But we're not factoring, we're expanding. So the next thing to do is we're going to expand into individual terms. So we're going to multiply this into here. We're going to multiply this into here. We're going to multiply this into here. Now we get x cubed plus 2x squared plus 3x squared plus 6x plus 2x and plus 4. There's our expanded answer. This is technically correct, but it is not simplified. We're going to go ahead and combine like terms to simplify it. And that is how you multiply polynomials. You simply take one polynomial, distribute it into each term of the other, and then simplify the equation. The 3 steps to multiplying polynomials are as follows. You first need to identify whether the polynomials you're multiplying follow any special formulas, such as the difference of squares. If so, you can follow that formula and save a lot of time. If not, distribute one polynomial into every term of the other. You then multiply into the brackets to create a ton of individual terms. You should get rid of all the brackets this way. Finally, you will simplify the polynomial by combining all like terms.